the availability of energy is the issue.
Hello everyone, this is Professor Fang. Recently, Elon Musk got an interview and mentioned that in next 33 months, the cheapest place to put AI might be in space. So people hear and immediately feel that, okay, it's a sci-fi, it's another Elon claim. In this video, I will give you the fundamental logic behind it. It's about the science and also about the business. If you see space computing as like a satellite, a solar panel, rockets, this and that, I think you missed the point. You should go all the way to the deepest fundamental. I tell you one classical optimization reality, which is when constraints change, the optimum shifts. In this video, I'm going to do three things. First of all, explain why space compute is worth taking seriously. There are two constraints that are actually changed, which cause the optimum point change. Second, I will walk through Elon's reasoning. He starts with a power bottleneck on the Earth and then derive space as a solution. Third, I will summarize the host's toughest challenges about the heat, maintenance, radiation, bandwidth, and etc., and how Elon answered them using the scaling law and the basic physics. And at the end, I will share my personal approach to this. I treat this as a mental experiment, and yes, I'm willing to put real money of myself into it, so I take this mental experiment seriously. I can learn a lot, and my judgment can increase significantly in this process. Remember, all investments involves risks, so you have to do your own study. Let's go back to the key principle, which is when constraints change, the optimum shifts. It is a very straightforward optimization problem, right? Most of people keep walking the old path because it used to work. But if the boundary condition changes, the old best answer becomes the new trap, right? So the key question is, what constraints actually changed in the past few years? Constraint 1. Launch capability changed. So space access is no longer purely a national prestige project. Reusable rocket turned it into something that you can scale just like an industry, right? The constraint 2, AI has proved that it has a real value. So it's no longer a PowerPoint technology anymore. I think a lot of us has experienced the powerful AI from ChatGPT, Gemini, Grok, right? So there are two constraints that changed significantly. So the optimal point will change. So here is the Elon's playbook. He created demands to scale a capability. To understand Elon, you have to understand his playbook. When he wants to iterate Falcon 9, he needs a lot of launches. But the thing is that at that time, the world didn't even have enough demand to fit that learning curve. He has a lot of launching capability, but there are not much satellites. So he created a demand, Starlink, right? That's the key. Truly scalable engineering is really powered by pure will. Okay, I have $100 billion, I want to do A and B. That typically will not work if you look at the Soviet Union, right? So it should be powered by economic loops. So if Starship jumps straight to the Mars, there's a demand problem, right? No demand, no profit, so you have to burn your own money, which is limited, even though he's the richest guy in the world, but it's still limited. So if the constraint changed, he needs a few demand engine to iterate his Starship. Eventually, he can go to the moon, he can go to Mars, right? So the AI might be the biggest demand engine available so far. Putting computation into space is largely benefit to Elon because he has the deepest moat, which is his launching capability, right? If he make this story, the space data center will replace the Starlink to continue iterating his Starship. So if this race begins, every other giant is forced to fight on Elon's home turf, rockets, right? So let's talk about the Elon's derivation. So in the interview, the host asked, how do you get to space compute? Elon's reasoning actually is very engineering style. He doesn't start with like space is very cool. He starts with a bottleneck, power. On Earth, concentrated compute hits constraints like grid capacity and interconnection, land and cooling, regulation, permit cycle, infrastructure build timelines that are much slower than the demand of the AI. he saw that Earth becomes an increasingly constrained place for AI. So he looked for a path that is different, with different constraints, no regulation constraints so far, so which is space. Okay, up to now, I want to ask you a question. What do you think? Do you think next AI bottleneck is chips or power? And in the comment, please let me know and let me know your insight. If you like this kind of like a physics plus optimization style analysis, please hit the subscribe button. Then we go to the host challenge. Host actually challenged a lot of tough questions and Elon answered them. I really enjoyed it. So the challenge 1, heat ejection. There's no air in the space, right? So no convection, no fans, right? Elon's answer to this heat dissipation issue is actually very direct. You can increase the temperature of the chips. So the heat can be only radiated. If you look at how radiative power scale with temperature, is actually T to the power of 4. So if you increase temperature from A to B, the radiative power will increase from A to the power of 4 to B to the power of 4. So it's a superlinear increase. So if you move chips to space, actually the constraint change and the optimum point will change. On the ground, maybe you are building a very nice chip, which is well cooled, right? But if you move that to space, the constraint change, the optimal point will change. Maybe you want something very robust and hot chips, right? So challenge 2, maintenance. What happens if a GPU fails? Elon actually points to the infant mortality in hardware. Many failure happens early. After you burn in on the ground, actually the reality improves. You have to test it on the ground with a very harsh environment, similar to the space, and then you iterate until you find the optimal point for the space computing. So the third challenge is about the radiation and the bit flips. The radiation causes error. The Elon's claim is that the neural network is actually pretty tolerant of random bit flips than traditional software. You still need certain types of shielding and redundancy design, so that's not a problem. Another challenge is about the bandwidth and the interconnect. The host actually pushed how do you replace effectively infinite terrestrial connection. In the ground, you can do anything, right? Elon actually did not fully detail here. Instead, he keeps returning to this main point. Earth is a non-bottleneck path. So you have to go a different path. Of course, putting computing into the space will meet a lot of difficulties, but there will be solutions. And yes, actually, if you look at the paper from Google, the Suncatcher work actually explores the terabyte per second class optical interconnect plus flight formation as one approach. So the last two are very challenging ones. And then the host actually asked Elon about the launching capacity. If you want to scale in space, a year you have to launch 10,000 Starship. That's actually 1 launch per hour. Elon compares it to the traditional aviation. If you think about it, how many aircraft are there right now in the air? There is a YouTuber who created an animation. You will see it's much larger than the launching frequency of the Starship. So Elon already looked at the Starship launching and compare it with the traditional aviation. Actually, Elon even suggested that with the dozens of Starship, you can reach 10,000 launches per year because you just turn over it very quickly. And lastly, most sci-fi part is about launching from the moon. Lunar manufacturing is some kind of inevitable path in my mind to reach the Kardashev scale too. Here's my opinion, which is that lunar manufacturing is kind of inevitable if you want to reach the higher energy level in the Kardashev scale. So Kardashev scale simply says that the type 1 roughly can use the planetary scale energy, and Kardashev scale 2 is a stellar scale energy, harvesting a meaningful fraction of a star, which in our case is the sun. And the type 3 is the galaxy scale energy, which is way beyond our control. So currently human is not even a Kardashev scale 1, is 0.7 something. If you want to go to Kardashev scale 2, you have to go to harvest a meaningful fraction of the star, which is the sun. But the problem is that the sun is radiative. As you move closer to the sun, solar intensity increases roughly as 1 over r squared. right? So it's actually superlinear increase. If you want to capture meaningful fraction of the solar energy, you have to get closer. The delta V will be big if you go all the way from the Earth to the Sun, right? So lunar manufacturing is one of the paths because of the low gravitational force. Lastly, I will mention about my mindset. So these are big picture thing, right? Let me be clear. I say a lot of good things about Elon, but I'm not like worshiping him. I'm not here to believe in anything. Here's my plan to get most of the technological revolution. So I have a simple rule. If I want to take something seriously, I have to put money into it. So I'm not gambling my life, so I put 10% of my net worth into this space stuff. So I'm taking this problem seriously and gather information as much as possible and analyze it from the fundamental way. And I will document everything I have. For example, the data collected, assumptions, my reasonings, and weak points. So in 5 to 10 years, I have 2 axes. One axis is I lose money, I gain money. The other axis is my logic is right, my logic is wrong. So I have 4 possibilities. If any of those possibilities happen to me, I either make money or lose money, but in any case, I learned. Until 60, every 5 years I do this, I still have 6 times to train my deep thinking ability. Until I'm 60, I'm not just getting older, I'm sharper because I've trained myself with real money bets into those technological trends, see through those superficial things to see the optimization problem behind it, the physics behind it. That's the video for today. Remember, subscribe, and I will see you next time.